Okay, hello. So today we've got a kinematics question in rectilinear motion, and we're looking at an A versus S graph. So I'm just going to read the question first. So the question says the AS graph for a race car moving along a straight track has been experimentally determined. If the car starts from rest at S equals 0, determine its velocity v when S equals 300 feet. So what is an AS graph? Well, it's A, which is acceleration here, which is in feet per second squared, versus S, which is here, and S is in feet. A is your acceleration, S is your position. Okay, so what do we know? So we know that from 0 to 150 feet, the acceleration is 10 feet per second squared. And then from 150 to 300 feet, we've got an increase. So we'll have to come up with a function for that. All right. So if we begin, we have A equals 10 feet per second squared. And that is from 0. S is 150 feet. So basically what that means is from 0 to 150 feet, so from 0 to 150 feet, A is just this 10 feet per second squared. Actually, what we can do is put this in a piecewise function, and then A equals, so we need to come up with a function here, because it's not just a constant value, and that's from 150, S to 300 feet. So we need a function there. So if you can remember your high school math, it's actually pretty simple. So in high school, if you remember, we had y equals mx plus b. And that's essentially what we're looking for because we have basically an incline. All right, so what is m? Or actually, what is, let's just change this first. So y equals mx plus b. What we actually have here is a equals ms plus b, where we have acceleration and position, and then m is going to be our angle that we have, and then b is your offset. So we need to find our m value first, which is really easy to find with your simple rise over run. So 30, I think it was 30, 30 minus 10 over 300 minus 150. If we punch that into our calculator quickly, minus 10 over 300 minus 150, we get 2 over 15. Okay, so 2 over 15 S plus, or I should leave that for now. So we take a value of A and we sub that in. So at A is 10. So 10 equals 2 over 15. And we find a value for S, which is 150, plus B. And then we just solve. So we've got 2 over 15 times 150 is 20. So 10 minus 20 equals B, which is negative 10 equals B. So this is minus 10, and we should put this into brackets and feet per second squared. So let's start off by finding v from 0 to 150, because that one's pretty easy, but it sets up what we're going to need to do. Now, I'm not going to explain necessarily how to do an integral, because I hope that you kind of have an idea. I might do a video specifically on how to do integrals if there's some interest in that. But let's see here. So from S naught is just your initial position. So what I'm doing here is acceleration. We're doing the acceleration integral with respect to S, which is your position, equals the velocity with respect to velocity. So the change in velocity, basically. And so we know from 0 to 150 feet, S naught, this is 0, right? Because our starting position is 0. We have A, which is up here. Maybe I'll use a different color. This A is 10 ds equals v0. This is just v dv. And so then we just solve the integral. So if we know how to do an integral, since there's no s in here, there's no s there, so this just becomes 10s, very simply, equals, and v, yeah, okay, so I said I wasn't going to, but we'll do it quick. So to do an integral, you have n plus 1 over n plus 1. So in this case, v is just v, so it's 1, and this is 1, so it's just v squared over 2. Okay, so we've got v squared over 2, and then we just want to solve for v. So v squared is 20s, therefore v is the square root of 20s. So when we are at 150 feet, so when at s equals 150 feet, v equals 20 150, which is square root of 20 times 150, which is going to be 54.7723 feet per second, or maybe just 54.77 feet per second. All right, but you can use this this equation here for anything from 0 to 150 feet, basically. That's how you set that up. So now, instead of just having a constant acceleration, we want to find out this part, because that'll tell us what the velocity is at 300 feet. So we just set this up exactly the same. ADS is VDV, and our A is from S150. So the integral, remember, if you remember, the integral, we were integrating first from 0 to 150. Now we're integrating from 150 to 300. So from 150, which is here, to our final point, which will be 300. All right. So what do we have here? We need to look back at this. This was 2 over 15s. 2 over 15s minus 10 ds. So we're just subbing in a, right? A is this whole thing. So we're just putting that in here. And that equals V, and this is V, so this is actually, or this is not S150, this is 150. And this is 54.77. That was this value here. So that's where we were, and this is where we were, this is where we're going. That's what we're integrating over. And we just do V dV again. All right. So this side of the equation, I'm just going to split this up. So this side of the equation is pretty easy. It's the same thing, V squared over 2. And again, I hope you guys know how to do an integral, but I can go through a whole video on how to do that if you want. And then this side, we've got, what is this? This is s squared. This is 2 over 15 times 1 over 2. So that's going to cancel. So we've got 1 over 15 s squared minus 10s. Okay, we made that a little big. S squared minus 10s. Oh, we almost forgot. Very important. S and 150. All right, so from here, we would just solve. So we know what we're solving for S. We don't know what we're solving, like we don't know the value of V, but we do know the value of S. And S would be 300, right? Because we're going to 300 feet here. So we would just go plug all this in. 300 squared minus 10 times 300 minus 1 over 15 times 150 squared minus 10 times 150, which equals V squared over 2 minus, I guess we can just go 1 over 2 times 54.77 squared. I don't know where that came from. Squared. Yeah. So if we just punch that into the calculator, sorry, just bear with me here. 115, 300 squared minus 10 times 300 minus 1 over 15 times 150 squared minus 10 times 150. This is 3,000 equals E squared over 2 minus whatever that is. Yeah, I guess 54.77 squared over 2. 1499.87 645. So 3,000 plus this number is 4499.87645 equals v squared over 2. This number times 2 is 8999.7529 equals v squared. Therefore, v is the square root of that number, 29. So at s equals 300 feet, v equals, let's see what this number is, 94.87 feet per second. Feet per second. All right. And so that's how you solve that. So I hope that all made sense, and I hope I went slow enough for everyone, and not too slow for people that were just looking for the answer. Definitely make sure to like the video, subscribe to the channel if you can. This is still a fairly new channel in terms of I haven't been posting that many videos yet, but I would like to move into some other stuff. Let me know what you'd like to see more of. Do you want to see more of this kind of math? Do you want to see a different type of math? Do you want to see some physics? What are you looking for? Definitely let me know down in the comments, and I will try to help you out with whatever it is that you're working on. Thank you so much again, and until next time, take care.